So I'm going to switch us over to science and technology. Just return. What's going on? I'm switching us over to science and technology for the NASA QUESST Rollout. Let's see what happens. Oh, yeah. Okay, that'll begin in about 6 minutes. I'm just gonna go get another fresh pot. Hey, Yul, look. Are you pissed? Are you pissed? Mr. Snibbles, add time? Fine. Fine, we will add time. Hey guys, did you know I have a shirt like this in real life? I don't know if you knew that. Alright, I'll roll. What did I roll? Oh, I rolled a 1. Okay. Alright, enjoy your ads. I'll be right back. I'll be right back. I just gotta go out to the shop. I gotta make some coffee. Gotta make some freaking coffee. Alright? All right. So you guys wanted the chrome, huh? All right, cool. I was wondering if you wanted the chrome or the regular, you know? No, you didn't. Nando, you didn't want the chrome? And also, why am I making coffee in the shop? Because my office is connected to a garage, which is in the woods. in my backyard in the middle of nothing. So it's like I don't know, an eighth of a mile to the house. I mean, it's less than that. It's way less than that. Maybe a 16th of a mile. It's not that big. We're not in the future, so we can't have chrome. Yeah, chrome would look better on a white truck than the black. Yeah. Okay. All right. I got you. Does a garage poop in the woods? That's a good point. Have you tried restreaming from NASA Plus? No. JATO rocket upgrade? It's a truck, Neuro. Truck's looking good, though? Thanks, dudes. I haven't made any progress on it since New Year's Day. That was before I got sick. But anyway, let me tell you guys about the Quiet SST. So what are we here for? Enough with the truck. What are we here for? We're here for that thing. So what's that thing? Other than looking like a platypus plane. So this is NASA's Quiet Supersonic Transport. So what this plane is designed to do, amongst other things, it's an aerodynamic test bed for a plane that has a very certain shape. If you notice, it's got like a duckbill on the front. Basically, what this plane is designed to do is it's exactly as the name actually says. The Quiet SST is built to pioneer. It's built to pioneer a type of shape that makes no sonic boom. Well, two things. It doesn't make no sonic boom. It actually, the shape of the plane is designed to dampen out the sonic boom. Okay? And not only is it designed to dampen it out, but it's designed to take whatever sonic boom that it makes and shoot it up into the sky, not down towards the ground. Funny thing about sonic booms is that they're directional. So, like, if you watch a rocket going up into space, you don't hear anything. You don't hear it break the sound barrier, right? But, like, take like a Falcon 9 coming back down and landing, you're definitely going to hear that. Or, you know, if you're a fossil like me, if you hear the space shuttle coming back, you hear the twin sonic booms. So, sonic booms are directional. It kind of works like a speaker. You know what I mean? This thing is designed to make as little of a sonic boom as possible. And what sonic boom it does make, it pushes it up. All right, so they're going to roll out the flight prototype today. And I want to see this thing roll out because this plane looks... It's one of those things that looks very bizarre when you first look at it, but the more you look at it, the cooler it gets. So without further ado, let's see what our buddies over at NASA's Aerodynamics department are up to.
Everyone joining us here today and via live stream, welcome to Palmdale, home of the legendary Lockheed Martin Skunk Works.
Clap.
I'm Eric Fox with Lockheed Martin Aeronautics, and I'm proud to be your MC as we unveil the newest experimental aircraft we have been developing for NASA. We're pleased to have with us today distinguished guests, Pam Melroy, NASA Deputy Administrator.
What accent is that?
Jim Free, NASA Associate Administrator.
Like the
Don't be
southern.
afraid to stand up and do a little queen wave. It's okay. We're all.
That's southern.
Dee Dee Myers,
Texas,
representing Governor
Texas,
Gavin Newsom.
Arkansas, Louisiana.
Palmdale Mayor Austin Bishop. State Assemblyman Tom Lackey. And representing State Senator Scott Wilk, Jack Danielson. And finally, Greg Ulmer, Executive Vice President, Lockheed Martin Aeronautics. And many other government, Lockheed, and NASA guests. For 80 years, the Skunk Works team has innovated to develop state-of-the-art capabilities and aircraft. It is an honor to be here with you today to witness a new chapter of this history as we celebrate the rollout of the X-59. a truly unique and revolutionary aircraft, which is just behind this curtain. I know you all want to see it, and we'll get to see it, but there are a few people who are eager to meet you first. At this time, I'd like to welcome our host, Vice President and General Manager of Lockheed Martin Skunk Works, John Clark.
Cool. Skunk Works, baby. Johnny!
So, good afternoon, ladies and gentlemen, and welcome to the rollout ceremony for the X-59, a one-of-a-kind supersonic X-plane designed and built right here in Palmdale, California.
You got some hat hair.
It's rare that we have the opportunity to host this many visitors at the Skunk Works, and it's even more rare that we're able to publicly unveil one of our aircraft. Today we are witnessing history as we roll out the X-59, a unique experimental aircraft designed to quiet the supersonic boom.
Yes.
I want to emphasize the significance of this project and the genuine passion that drives our team at Skunk Works. Skunk Works has been a home of mine for nearly the entirety of my career. I consider myself extremely fortunate to work in an environment that fosters innovation and relentlessly pushes the boundaries of aerospace technology. The X-59 has the potential to shape the supersonic travel over land, cutting flight times in half of what they are today. But the X-59 is not just about cutting-edge advancements. It represents the best of our collective team and our unwavering commitment to make a positive difference in the world. I'm truly honored to be a part of this incredible journey surrounded by the best and the brightest of our industry.
There's always one.
Take on this challenge alongside our suppliers and NASA, who has been a great partner along the way, whose quiet supersonic mission has the potential to transform commercial travel for the future. Across both teams, talented, dedicated, and passionate scientists, engineers, and production artisans have collaborated to develop and produce this aircraft. This project is just one of an example of the broader ingenuity of our team as we continually strive to push the envelope of what's possible. I'm thrilled that you're all here today as we unveil the X-59 and celebrate this very significant program milestone.
I believe it's
Thank you.
You're welcome.
An aircraft like this does not come together overnight. It takes years of collaboration with a dedicated team, a team willing to overcome unprecedented challenges and challenges that require leadership with vision. It is my pleasure to introduce Executive Vice President of Lockheed Martin Aeronautics, Greg Ulmer.
Thanks, Eric. Deputy Administrator Milroy, distinguished guests, ladies and gentlemen, and everyone with us today via live stream around the world, thank you for joining us. It's a pleasure to be here today at our renowned Lockheed Martin Skunk Works facility to celebrate the X-59, an experimental technology demonstrator that has the potential to completely revolutionize aviation. Put simply, today we are all witnessing a defining moment in aviation history. And the Skunk Works mantra of quick, quiet, and quality takes on a whole new meaning as we usher in the hopes of a new era of quiet, supersonic travel made possible through our collaboration with NASA. Lockheed Martin and NASA have partnered since the agency's founding in 1958, pushing the boundaries of scientific technical limits to explore the unknown and advance both civil aviation priorities as well as those in support of our national defense. Together, we've collaborated to support all 22 NASA missions to Mars. We've developed X-planes together, and we've accomplished many aviation firsts together. And we developed those developments have had widespread impact for both our nation and the world at large. And today we celebrate another breakthrough as we roll out the X-59, an X-plane that will shape the next era of supersonic flight. Over the last decade, our teams at both NASA and Lockheed Martin, as well as with our suppliers, have been working diligently to mature the technology necessary to get to this moment in time. I am continuously impressed by the team in the innovation design and advanced digital engineering techniques that went into the development of the X-59. The team used advanced manufacturing techniques such as augmented reality, robotic drilling, and 3D modeling work instructions to help condense aircraft assembly times. We all know that designing and producing a one-of-a-kind aircraft is never an easy feat.
You 3D
And
modeling,
the X-59 is certainly no exception.
Big deal.
The entire X-59 team leaned into the expertise of both legendary organizations, NASA and Lockheed Martin, to ensure success for this program. And I am extremely proud and humbled of the entire team
They're using Blender
to make this historic moment possible. With the first flight on the horizon, I know there is much more work to do, but I hope everyone in this room, everyone who put all their elements together to be a part of the success of the X-59, that we pause and take a moment to reflect on all the work that has been accomplished in this important milestone as we're here today to celebrate. This is a moment future generations will look back upon with both awe and admiration. On behalf of the Lockheed Martin Aeronautics team, we are extremely proud to support NASA in making flight quieter in the Quest mission. Congratulations to our NASA teammates, to Lockheed Martin, our talented and dedicated suppliers, for your commitment to delivering the X-plane that will truly revolutionize supersonic flight, and proving once again that with a mighty, joint, committed team, anything and everything is possible. Thank you.
Is this audio making anybody else's ears hurt? Like it's... like the low is overdriven? Yeah, baby. Okay, Taco. Yep. Andy. That's actually super freaking cool. Oh, wow. Cool. Laughs in droop snoot. That's actually super neat. Cool.
It's absolutely inspiring to see how the X-59 team worked together and how much it means to each person who worked on this airplane. Please join me in welcoming NASA's Associate Administrator for the Aeronautics Research Mission Directorate, Bob Pierce.
Thank you. It's great to see everybody today, this afternoon, as we celebrate this really momentous occasion. And I admit it's a challenge to take our focus off what we're about to see, the X-59. the centerpiece of our Quest mission to explore quiet supersonic flight over land. But just for the next few minutes, allow me to expand your focus to a journey of scientific and technical discovery that got us to where we are today. This journey actually began in 1947, when the era of supersonic flight started right here in the California high desert with test pilot Chuck Yeager and the X-1. It soon became apparent that the sonic boom, a sharp, thunderous sound heard when an aircraft flies overhead at supersonic speed, was going to be a problem. When the Concorde started to fly in the 1960s, ushering in supersonic passenger flight, concerns about the boom remained. And in 1973, commercial supersonic flight over land was banned by enforcing a speed limit. But we continued to study the science of supersonic sound, gaining key knowledge about how sonic booms affect people and how to reduce their volume. The new century brought a boom breakthrough. Innovative ideas, advanced simulation, ground and flight testing showed us it was possible to design an aircraft that would produce a soft thump instead of a sonic boom.
Hey, Jackson.
Is
Thank
the
you,
thump
man.
quiet enough to allow supersonic flight over land? Our laboratory studies would say yes, but the real answer can only be found by engaging the people who would hear it during daily life, and that's the job of the X-59. After a test phase, the Quest mission will fly over the X-59 over U.S. communities, collect data from the people below, determine if that sonic thump is acceptable, and then turn the data over to U.S. and international regulatory authorities in hopes to then lift that ban. But look, to be acceptable, supersonic flight must also be sustainable. Takeoff and landing airport noise shouldn't be louder than regular subsonic aircraft. High-altitude emissions should have minimal or no long-term impact at the higher supersonic cruise altitudes. Efficiencies while in cruise mode must be significantly increased, and sustainable aviation fuels will reduce emissions further. At NASA, we're pursuing the key knowledge required for sustainable air travel at any speed. In closing, what we're about to see represents a nearly 100-foot-long step forward in the journey of discovery that began decades ago, a step toward opening the door to sustainable commercial supersonic flight over land. And while I have a few seconds, I just wanted to thank the NASA and Lockheed teams. I've had the pleasure and the privilege of watching them work, of visiting them, talking with them, and working with them. And that video you saw, the dedication you see, the excitement you see, the passion you see, the expertise, that's what this is all about. It's about the people behind the mission. That's what this is about. And I couldn't be prouder. And our two project managers sitting side by side, NASA and Lockheed, Kathy Baum and Dave Richardson, they work so closely together. They make this happen in their teams. And the teams that surround this are just, I can't thank you enough. So with that, thank you all for being here today.
All right, we're getting closer. Who all's excited to see an X-59?
Yes.
Yeah, I'll give you a B- on that. Y'all are 150 people in the world that are here live. How many people are excited to see the X-59? That's what I'm talking about. I now have the honor of inviting to the stage NASA's Deputy Administrator, Pam Melroy.
Shuttle pilot. Pam's pretty cool.
Thank you so much, Eric. It is just
Who said
awesome,
sit
ladies
down?
and gentlemen, and our distinguished guests, to be here in the vibrant, beating heart of what I consider the flight research and flight test capital of the world. Here in the Antelope Valley, I spent my time as an Air Force test pilot at Edwards, and it was like going to an air show every day. Absolutely amazing. What better place could we be for this magic moment? I also want to welcome the aviation enthusiasts, not just those of us in the room, but literally thousands around the world who are joining us remotely from over 20 countries and over 6 continents.
Literally, we're not reading,
so you
we're
are
watching.
also very welcome, and we're very happy to have you with us. Today marks a historic milestone for us as we unveil the X-59. This is really another jewel in the crown, not just of Aerospace Valley, but also a very rich history
she's reading. Okay.
of NASA Aeronautics.
Yeah.
The first
All right.
A in NASA stands for aeronautics, and we're all about groundbreaking aerospace innovation. The X-59 proudly continues this legacy, representing the forefront of technology
You're right.
driving aviation forward. The X-59 transcends its role, as all X-planes do, as a simple aircraft. An X-plane is a symbol of our collective ambition to redefine the future. And in this case, it's the future of supersonic travel. As we unveil this technological marvel, it's really important to understand the profound impact the X-59 holds for the aviation industry. Designed as a jet capable of breaking the sound barrier, the X-59, of course, distinguishes itself, as you have heard, with its revolutionary quiet supersonic technology,
but we haven't
enabling
heard
it to actually transition and be used. Today, supersonic flight brings a thunderous sonic boom. Those of us who live in the area are familiar with the sound. But what that means is that's restricted across populated areas with good reason. And the X-59 is going to break that barrier.
Oh.
Meticulously engineered, it produces a gentle bump, a mere whisper compared to the disruptive booms of the past. So this breakthrough really redefines the feasibility of commercial supersonic travel over land. It brings us closer to a future that we can all understand, cutting flight time from New York to Los Angeles in half. As we unveil the X-59, let's celebrate the aircraft, let's celebrate the team, let's celebrate the spirit of innovation and the human ingenuity that it is embodied in this aircraft. It symbolizes our collective ability to push boundaries, to overcome challenges, to dream as humans beyond the present, and shape a future that promises progress for everyone. So embark with us on this journey into the future of aviation. The X-59 awaits. Ladies and gentlemen, are you ready to see NASA's newest X-plane?
Oh, and a fantastic putt.
Me
Fantastic
too.
putt.
Well, then let's see it.
My ear holes are ready. Oh, a video. Quiet supersonic transport to chill on and fly across the country to. Oh, that's sharp. Oh, ho, ho, that's sharp. Oh, come on, dude! That's the same guy! What are you doing? that's sharp. Nice freaking plane. Oh, dude, they got the smoke machines. Look, they got the smoke machines going. Oh, damn. Spared no exp- and the strobes. Oh, this is great. I just want to see the plane. Ah, yes. Nubian. We got lots of that.
I'm sorry, you can keep looking at it, but I got a few more things to say.
No.
Behold, our
Behold!
X-59. What a unique aircraft, and it's just incredible to see the ingenuity that went into it. As a test pilot, the first time I looked at the design, I went, huh. Really had some questions about that. Lots of great time with the scientists and engineers at NASA, Lockheed Martin Skunk Works, and all our other industry partners. And I was ready to go. In fact, I'm ready to climb in, but I won't do that, Nils, I promise. I think it's really also important to take a moment and talk about the challenges of sonic booms accompanying supersonic flight. We talked a little bit about it, but this specialized aircraft is tackling it by engineering a specialized aircraft shape. What's most obvious right away is the long, distinct nose, which comprise almost a third of that 99.7-foot length. So this design is really critical in dispersing shock waves, which today, shocks are formed around the aircraft and then they merge together to give that boom. By designing it to disperse those, they never merge together, And that's how they solved this problem,
Yep.
which is really incredible. And then to further enhance its quiet supersonic capabilities, you can see that cockpit is positioned almost halfway down the length of the aircraft. And as has already been brought out,
It's a looker.
the
What a
forward-facing
looker.
window was getting in the way of keeping the aircraft quiet.
They're not canards,
And
they're
so
winglets.
that's why it has no forward-facing window. It was a deliberate engineering decision from the X-59 team to make this aircraft quieter.
Oh.
But what's really interesting about that is we made that decision to make it quieter, but it's actually an important step forward in and of itself in advancing aviation technology while prioritizing the comfort of
move,
those on the ground.
Winglets do not.
And huge challenge, right? Limited visibility in the cockpit. The team developed the external vision system, which is really a marvel of high-resolution cameras feeding an ultra-high-resolution monitor. Beyond its immediate applications for the X-59, the external vision system has the potential to influence future aircraft designs where
That's
the
cool,
absence
DCMD.
of that forward-facing window may prove advantageous for engineering reasons, as it did for us.
Well, where it flies,
so
you
it's
need to-
creating
you need to be
capabilities we
certified
haven't
on
felt
IFR
comfortable
trudging.
about putting in a crewed flight vehicle without first testing it. So this groundbreaking technology is really a beacon guiding us towards a future where visibility barriers in aircraft design can be overcome with this inventive solution. But the X-59's
You can play
innovation
Flight
doesn't
Simulator on
end
it,
there.
Hypemare.
We also designed special features into the airplane,
no, just flight.
such as its top-mounted engine with a deck under the nozzle, which ensures that the shock waves don't merge behind the aircraft and create that disruptive shock below.
Yeah.
This isn't just an
Also,
airplane.
what she was talking about is back
This
there.
is an X-plane. It's a manifestation of a collaborative genius. And as Bob Pierce noted earlier, the culmination of decades of scientific exploration around the sonic boom. I'm really personally thrilled about this engineering marvel taking flight.
Nah,
and as
Pins,
we
not really.
embark on this journey, let's celebrate the X-59 as a symbol of progress and a herald of quieter supersonic travel, which will bring us closer together as humans faster. Thank you, and please join me in welcoming NASA's Associate Administrator, Jim Free.
Jim's been busy this week.
Thank you, Pam. Good afternoon. I try and learn every day, and I learned a long time ago, don't follow an astronaut. Now I learned don't follow your boss, and now it's don't follow the unveil of a new X-plane. So I'll stow that one away. Thanks so much for allowing us to be here, and welcome certainly to all the distinguished guests here today, and the most
Pretty much
distinguished
think
guests,
like, yeah.
the team that worked on the X-59 from both NASA and Lockheed Martin. NASA is committed to aeronautics innovation. Our X-plane investments show this commitment completely. It's exciting to see an X-plane in person, really is for a space guy. The X-59 is joining a long line of NASA experimental aircraft used to validate breakthroughs that change aviation forever. Even among other X-planes, the X-59 is special. Every aircraft that receives that X-plane designation has a specific purpose to test new technologies or aerodynamic concepts. These special planes push the envelope of what's possible in flight. And once they prove those concepts, they often go into museums. And that's really what makes the X-59 different. Once we evaluate its ability to produce those sonic thumps, its work will just be getting started. This plane will spend years traveling around the country to conduct community overflights. After its first test flights, the Quest mission team will expand by thousands of U.S. residents very soon. The people we're relying on to give us honest, unbiased feedback on the X-59's noise will be the key to getting the data we need for the mission to be a success.
This is the rollout, Rhino. It has
Now
not
my
flown
favorite
yet.
part. I want to focus on the dedicated group of people whose innovative work has made the X-59 possible. Some of the brightest minds from NASA and Lockheed Martin Skunk Works make up this team. Aerospace engineers, mechanical engineers, electrical engineers, technicians, pilots, support staff, creative types, and so many more people whose hard work brought us to today. Thank you for
Gotta pay
every
extra for
single
that,
moment,
Arcadio.
every single effort, And I'd like to take a moment and ask that all of you give them a round of applause.
And it's a beautiful putt, Jim. And he must be really happy he parred that hole.
This team is the personification of perseverance. In addition to the challenge of designing, building, and integrating a brand new, one-of-a-kind X-plane, which they've met, this team overcame these obstacles during a global pandemic to bring us to the cusp of expanding our horizons into a new era of flight. This is such an exciting time in aviation, and NASA is glad to lead this historic mission through Bob Pierce and our Aeronautics Research Mission Directorate. Our innovators worked with the skilled team at Skunk Works to complete the build of this X-plane. Their work has been critical to the continued success of the mission. Entire careers, we are talking decades of people's lives, focused on supersonic research, have gotten us here today. This team is continuing to build on the legacy of aeronautical research and also advance the research with different aircraft shaping like that of the X-59. Across all its aeronautics missions, NASA researches and innovates alongside with and in collaboration with our industry partners. Those partnerships allow NASA to create new technologies, new aircraft, new airspace designs, and operations. And they will help us develop community integration solutions that will make aviation more sustainable and integrated into our communities in ways that support U.S. economic growth and benefit the public with new and innovative transportation options. My sincere thanks to the team who have brought us this commencement, to the teams who will conduct these flights, to the teams who will collect and analyze the data, and to the American public who will become part of this mission. Thank you.
Thank you, Deputy Administrator Melroy and Associate Administrator Free. For those of you that aren't an engineer, that are listening to this on live stream, or you're in this room, let me just break this down for you. I weigh 240 pounds. If I were to jump off of this stage, land in a pool 25 feet back, 7 rows of live human beings would get wet when I cannonball into the water. That is currently aviation as we know it. What the X-59 does is it is a U.S. Olympic diver that you are going to see in Paris this summer. And when you see that diver go into the water, there's barely a ripple. That's what this does when it goes 900 miles an hour across the sky. It will barely make a ripple. So I know we all want to get a closer look at this incredible aircraft.
Yeah, I was kind of wondering where he was going with that.
One of our public servants who works to make projects like this possible for the American people. Please help me welcome Governor's Senior Economic Advisor, Ms. Dee Dee Myers.
All right, I was a little confused for a second, but you know.
Thank you, Eric. And let me just say,
that guy's like really excited about
Deputy
this.
Administrator Melroy, Associate Administrator Free, Colonel Kaspers, Greg Ulmer,
No, Dee Dee,
John Clark.
no!
On behalf of Governor Newsom and the people of California, welcome home. It's good to have you here. And let me just say, it's especially great for me to be here, as my dad worked at Lockheed, including at the Skunk Works, directing the reconnaissance programs in the 80s and 90s. So
yes,
on behalf of him, who still follows all this closely, who still has Skunk logo and merch, and still considers himself part of the team, again, it's wonderful to be here. And it's also a point of deep pride and personal privilege for those of us in California, because NASA's partnership with California is so important. It's larger than the partnership with any other state, and it brings tremendous benefits to our communities. An economic impact of $15 billion a year, over 1,800 proud NASA employees, and nearly 3,400 contractors and supply chain workers for a combined direct and indirect job force of 66,000 people here in our state. And more than $742 million a year in revenue. And if you've been following our travails, budget travails this week, you know how important that is. So to NASA, we simply say thank you for the business, thank you for your trust, and thank you for this great and ongoing partnership. As Senator Bill Nelson says, NASA gets things done. Things that inspire us, things that unite us, things that show nothing is beyond our reach. And this project certainly demonstrates that, the X-59. And we're just getting started in terms of the scientific benefits that this program will unlock. The X-59 is the first and only quiet supersonic aircraft in the world, which we've heard a lot about today. And no one should be surprised that it was conceived, engineered, and built by artisans here in California, because this is ground zero, not just in the country, but in the world for innovation and exploration. We're very proud of that here. So true to that legacy, the X-59 will push the boundaries of aerospace, advancing the future of commercial aviation. If you want to dream big and create something that's never been created or seen before, you come to the Skunk Works, you come to NASA, and you come to California. Yeah. Our NASA partnership dates back to Downey, California, and the Apollo project in 1960. So it's a long and proud relationship. And the X-59 is just the latest chapter in our innovation story that always starts with the audacious declaration, we can do that, right? We can prove supersonic flight without sonic booms. That is such an exciting beginning.
It is a
now,
big deal.
Here we are, once again, inventing the future and inspiring another generation of science lovers, science geeks, and STEM students all across the country to dream big. And we know those dreams will change the future and the face of aviation. It'll captivate, motivate, and educate communities all over the country about what's possible, including time travel, sort of, right? You'll be able to take off in New York City, fly 925 miles per hour, as Eric noted, and land 30 minutes before you take off on the New York-LA route. So it's not exactly time travel, but it's still pretty cool to think about for those of us who travel back and forth all the time. So we know that somewhere, Chuck Yeager and Kelly Johnson, two heroes in my household growing up, they're smiling at the legacy that they have created and left, and the inspiration that they still give us. Because it's another incredible milestone for NASA, for the Skunk Works, for Lockheed Martin, and for our partnership here in California. So we could not be more excited, we could not be more grateful to be making history with you all again, and what could be better than that? So thank you all for being here today and having me. Thank you.
I think she's a politician, so time travel.
Thank you, Dee Dee. Please join me in welcoming back to the stage John Clark for some closing remarks.
You could have just said it saves you time because it goes faster. I mean, all right.
As we close out today's ceremony, I'd like to thank all of you, especially our distinguished guests, and for all of you that have attended virtually. On a personal level, this airplane represents an opportunity to take half of my week and make it more productive. I wish I had it 25 years ago. I literally spend about a day a week on an airplane, and it would be great to have something like this, and the people that will succeed, all of us, hopefully are going to have that opportunity, say 2032, 2035. And there's going to be a lot of opportunity in the future to drive new innovations with new commercial transport airplanes based on the technology we're creating here. The X-59's future is bright, and that's all due to the individuals on this team. And I specifically want to call out my Skunk Works team and thank you for all the hard work and dedication that you've put into this. And to the NASA team, I really genuinely appreciate the partnership. The collaboration to make this all happen is very meaningful. Thank you.
He's very important, Taco. Did he say it's the seat? Yeah. Oh. Did ya? Oh, man, I'll tell you, that plane's a looker. Nice. Very nice. Very nice. Actual gameplay shown, not just rendered footage. That's nice. You're gonna fly it right now? Aww. Oh, hi, son. What's new with you? Is it hot in here, or is it just me? Are you winning, son? You know, a wise man once said, I want to turn into a jet and fly into the sun. I think that jet was the X-59, judging by what I'm seeing here. He's the boss, though. Yes, yes. Like a boss. Yep. You, door. You, me, gas station. Sorry. Dude, that, okay, so, all right, so Pam Melroy was talking about shocks. So what are shocks? Shocks are, well, things that come off of the plane when it's flying at high speed. Here, let me show you. See, look at. I'm not just glowing because I look good. Here, check this out. So this is an image of two T-38s flying at supersonic speeds. See these shocks right here? And see how some of the shocks are at different angles? They end up combining. And when the shocks combine, they make, wait for it, a bigger shock. Okay? It's like having 7.1 surround sound instead of 2.1, like a plebeian or a sound bar. All right. Okay. No, so when the shocks combine, you get a louder sonic boom. Okay? So with the T-38, you got all these edges right here. And the shocks do eventually combine, right? But sometimes, depending on, direction of travel, where you're standing relative to the direction of travel, right? Like if it's going up, right, the shock's going to go up, right? Think about it like a speaker that, if it kind of goes off in the directions that it's, wherever it's flying, right? Supersonic speakers, yeah. So that's why you generally, like with a fighter plane, if you do hear a sonic boom from one, you usually just hear a because by the time you hear it, these things have either dispersed or they've combined, right? See, this thing right here is called bow shock right there. Or just, it's regular shock. But anyway, see all these little things? All those little lines right there on the T-38s are breaking the sound barrier. The reason why is because the sound barrier is basically, it's based off of airspeed. So if you go faster, if the air is moving over a piece of the plane faster than the speed of sound, you can have parts of the plane breaking the sound barrier and parts that don't, right? But every time the air tries to change direction, like at the engine intake or at the wingtips or at the nose, you're going to get a shock because the nose is pushing the air out of the way, right? And the interesting thing is that, the faster you're going, theoretically, you can make a louder sonic boom, right? Because the angle of the shock entirely depends on speed as well. As you go faster, the angle actually gets steeper, I guess is the right way to say that. So, you go faster, theoretically you make a bigger boom, right? But what this thing is designed to do is dampen most of those shocks out, right? It's designed to dampen most of it, and the shocks that it does make is designed to shoot up in the air. That's why you have that platypus nose right there. Platypilled? Based in platypilled. All right, so that's why you have this here. So it's designed to deflect the shock upwards, believe it or not, and dampen it out. So theoretically, if you have a very, 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 very mild shock that's being vectored up, this thing shouldn't make any sound. It should make a b noise, something like that. Can it time travel? Well, no, yeah, maybe. I don't know. So that's actually a pretty cool thing that NASA's doing here. Really, 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 really cool. And the plane's a looker. Like, when I first saw this thing, I'm like, damn, that plane's butt ugly. But also, you know, it's it does kind of grow on you. It does look pretty rad. What would happen to anything flying above the X-59? You'd hear a sonic boom, Tithar, but nothing more than any other jet. You know what I mean? Now, a lot of you guys I saw asking questions like, "Oh, this has got to be for military research. It's got to be for military research." Nah, not really. NASA really doesn't do military stuff, and this plane was made for NASA. Now, that I don't think that stopped Lockheed from doing some R&D on how to manufacture planes. They said it was using 3D modeling and alternative reality. Planes have been using 3D modeling for fluid dynamic analysis and blueprints basically since the 80s. They do aerodynamic simulations, amongst other things. And, you know, obviously, I don't think anything that flies in the air nowadays is designed on a drawing board, right? It's all done in some kind of CAD, right? But that's not what the dude was talking about, I don't think. Now, in one of the promo videos, they showed exactly what was going on here. Let me show you, at least what I think. So he was talking about like robotic drilling, right? So they have, look, check that out. That's what he's talking about. This thing is not just, it's using an AR. It's using an alternative reality of the, not just the plane, it's the environment around the plane as well, and using robots to assemble this using alternative reality. So the robot will know where the part's going to go, and that's actually, I mean, that's like not a big deal with cars, I guess. That's not that cars have been doing this for a long time. I guess it's kind of a big deal to do it with an airplane, though. Augmented reality, yeah. Sorry, yeah. You know, you guys know what I meant, but you know, you're still gonna correct me. But hey, it's fine. You know, that doesn't get annoying at all. No, that's fine. So that's actually super cool. It's modeling the environment of the factory around it as well, and using robots to put it together. It's basically assembling the plane in 3D space and in reality at the same time. That's cool. It's called a digital twin, new tech. That is actually kind of a big deal. Building, no one builds planes like that. Not to my knowledge. So it looks like Lockheed used the X-59 to prototype the augmented reality aircraft assembly, which is really cool. That's really cool. Think about it like it's like proto 3D printing an airplane. It's not additive manufacturing by any means, but it's like a step towards that direction, which is actually that's super impressive, to be honest with you. I really kind of wish he'd said that, because I honestly had no idea what the heck he was talking about until I saw this video. The Air Force and the Space Force have lots of grants going out for digital twin tools. That's really cool, Rocket Guy, because yeah, I mean, me being familiar with CAD, if you can mimic the precision of CAD in real life and find an intermediary thing to basically A, build stuff at the speed that you build it in CAD, and B, actually manufacture it like with a robot, that's really freaking impressive, actually. Yeah, that's really, really cool. For real, actually. Then this turns into a real rocket building stream. Yeah, I don't think Lockheed will let me access the Skunk Works to make something, but yes, we could, right? Yeah, this looks like flyout. Yeah, having instantly updated CAD files every time you change something is a big deal. Yes, it allows for more rapid iteration, Jonathan. Bingo. You can basically build planes as fast as you can 3D model them. That's really, really good for prototyping. You know, that's great for X-planes. What if we ask nicely? Maybe. Yeah, I saw the signatures up there. I'm kind of just here looking at this. What is this? Fuel transfer system. So you have wet wings. Fuel's in the tanks. The fuel's in the wings. The fuel tanks are in the wings. Thanks, man. Thanks, brain. Really appreciate it. Why not try and make it in KSP? KSP doesn't model supersonics like real life sudden. It's just, are you going faster than the sound barrier? Yes. Okay, cool. Here's some condensation on your wings. Concorde. Ooh, that's nice. See? He's playing Flight Sim right there. See? He's playing Flight Simulator. That's all. I want to see more of these pictures. Hello. Yeah, that looks like a jet engine. You can tell it looks like a jet engine because of the way it is. "331 knots at 3,700 feet. Is that what it said? Yikes. They did a lot of digital twin, CNC, 3D CAD. So that's wind tunnel testing right there, I think. That's cool, Nero. Yeah, no, it's super interesting stuff. Is it an F-16 engine, guys? I don't know. Oh, yeah, that's trick right there. That is. That thing's doing all the rivets automatically, which is pretty friggin' impressive. Actually, what that thing is doing is drilling holes. It's not doing the rivets. That's not right. It's drilling the holes for it. Which, drilling through carbon fiber is a pain in the butt. You have to be very precise. Like, very precise. Or else you're gonna start eating away at the carbon fiber. I want to see if there's any more in here. I mean, the sub-assemblies are crisp, dude. Very nice. Very nice. It's an F414 GE100, which F400s are used on F-18s. Yeah, cool. It's just awesome. Dude, look at that. I mean, you know when we say, like, I really kind of wish planes, looked like how we expected them to look in, 2024? Well, I mean, here you go. It's not a passenger plane, Pigeon. It is a single-person test unit. So what they're going to do with this thing is basically fly it around overpopulated areas, see if people hear the boom. They're going to have it land and take off from airports. They're going to have it fly all over the country. Any airport that, where they think, supersonic transports could go. So basically every international airport, right? And what they're going to do is they're going to do a sound test at every airport, because every airport has a different approach. You don't want to just have this thing land and take off a bunch at Edwards. Just because you don't hear it at Edwards doesn't mean you won't hear it flying into JFK. You know what I mean? Nobody's out in Edwards. Edwards is out in the middle of nowhere. Foreign object debris. Yeah. Cover of Aviation Week. Nice. It is a nice looking plane. Definitely a looker. Not every airport that will allow it. Why would you not allow a test article to land and touch and go on your runway? Anyway. like set up listening posts to pull the population. I bet you they're doing all that different kinds of stuff. Hip hop. It'll be cool, man. Hopefully, you know, like for that. I mean, that's sounds like what they said. That sounds like what they meant when they said that. I don't know. That lunch area looks great, by the way. That'd be sweet to work in a hangar this big. If I had like that 50,000 viewer Twitch streamer type of money, I would have my streaming set up in a hangar like this, and there would just be hangar behind me, and we'd have stuff in the hangar, kind of like my hangar now, but it'd be way bigger. You know what I mean? Like way bigger. Yeah, no, like I would, the stream would start, and the start of the stream would be me like running across the hangar. I'd be like, oh gosh, I gotta get to the stream setup. Oh my god, and like sitting down. Yeah, that would be it. Yeah, exactly, McCory. Yep. Yes, nice truck. Nice truck. Could that be one of the shuttle hangars at Palmdale? It's not a shuttle hangar. The shuttle hangars are owned by Boeing. This would be the Skunk Works. This is down the street from it, so to speak. All right, let me go see if we can take a look at it again. That's the forward-facing camera right there. Oh. Thanks for tuning in. You're welcome. I'm not done tuning in, NASA. Quiet supersonic transport. Yeah, exactly. If I walk, the stream would be over. I like it, Rocket Guy. When I first saw this thing, I was like, eh. But with the paint done up right, she's a looker, man. It's a nice plane. Oh, that looks cool, man. That looks like something that flies in 2024. That's what it should look like. You know what I'm saying? Oof. She is a looker. Yeah, Bandit, I don't know either. I'm not sure. Oof. Yeah, the platypus nose is designed to deflect upwards. How's this going to be a passenger plane? Scale it up? Well, yeah. Yeah, of course, Agent Smith. What you're looking at here is just a small test vehicle that has one person aboard. What you just asked would be like looking at the X-1 and be like, well, how are they going to get 200 people on that? Well, no, they're not. They're going to build Concorde or something instead, because that would be silly, putting people on an X-plane. So basically, this will be for the bigwigs to fly around the country clubs, because no way us plebs are going to be able to afford tickets on these things. How did you extrapolate that from that presentation? Do you guys know what X-planes do, or do we just... maybe. So, guys, what this plane is designed to do is pioneer this type of tech. X-planes have been used in the past for anything from breaking the sound barrier to experimental space vehicles to... basically, I mean, dude, there's all kinds of different X-planes. They use them for hypersonic testing. Long story short, dude, even an X-plane in the past was like a Gulfstream or something. Not even a Gulfstream. It was a twin beach king, right? Well, NASA tested something in the 80s on the edges of the wings to prevent vortexes from coming off the wings. That was done with NASA's experimental research. We know them as winglets, and every single freaking passenger plane, every single new passenger plane has them. You know why? It reduces drag by preventing air from sliding off the side of the wing. This, Z-Money, this isn't the type of stuff that's like, oh, well, NASA's going to do it, and then there's people are going to make Gulf streams out of this. No. The X-59, what it's designed to do is rewrite the book on rewrite the passenger, basically like the FAA's rules on supersonic transport systems. So what this plane is designed to do is basically a benchmark to fly around and, understand how basically set the bar for quiet supersonic transports in the future. And then once, NASA and the FAA kind of collab on this, right? The FAA is going to have the rule set and the criteria for building something like this. And then after that, Lockheed or whomever, Lockheed, Airbus, maybe that other company that starts with a B, I don't know, could go about using the kind of open source data on building quiet supersonic transporters. Blorgen. Nuglins, Blorgen. But yeah, the X-59 is actually a super, super cool piece of kit. That's really, really cool. And it's a looker, man. It's a nice plane. Do you think the results will affect Boom's supersonic airliner? Seems like a bad time for them to be creating designs if they will be limited to ocean flights. Taco, if you were going to invest your money in Boom, do you think you would invest it not knowing that the plane is just limited to flying over oceans? Honest question. So you had like $500 million, right? And Boom's like, we're going to make supersonic transports. We're going to make low-cost supersonic transports. Would you invest the money knowing that they, without knowing that they can't fly over water? Or they can only fly over water? Can someone give me a summary? That's how it was the rollout for the X-59. The X-59 is a quiet supersonic transport. It is a plane that basically dampens the sonic boom. Doesn't make that much of a sonic boom, which is actually super cool. Long story short, Taco, no, I don't think this is going to affect Boom at all. I think Boom is probably keeping a close eye on this. But I don't think they would get any investment money if people didn't know, what they were getting into. Boom, there's a chance that Boom Supersonic, which is trying to bring back just regular supersonic transport, something like Concorde, I think they would know good and well the sonic boom rules for commercial flight before investing in a commercial flight supersonic transport company. I'm pretty sure. Do they boom at Mach 2? And that would help hypersonic? What would help hypersonic? Huh? So, guys, yeah, don't get what Boom is doing confused with what the X-59 is doing. The X-59 is trying to make quiet supersonic transport. Boom is trying to make low-cost supersonic transport. The two kind of big gates to building another Concorde is it's expensive and it's loud. Those are the two big kind of gates to breaking into that kind of, building that kind of aircraft. It's expensive to make and it's super freaking loud. Concorde was very expensive because it used military grade engines. It used military engines. The Olympus, which Rolls-Royce Olympus, very nice, with afterburners on it. So because of this, it was very, 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 very difficult to maintain. High maintenance cost. Second part, the other reason why it had high maintenance cost is because they couldn't get the dang thing to be profitable because the sonic booms were too loud. So if you wanted to fly from New York to Los Angeles, right? The FAA wouldn't allow it. The supersonic boom would hurt too many people's ears. And to be fair, with Concorde, the boom is extremely loud, especially when it's going Mach 2. Even up at high altitudes where the Concorde flew. It still flies in my mind, but it's just me hoping. It's like a cannon going off. I mean, these booms are no joke. They're really freaking loud. At what altitude does a sonic boom actually get to be inaudible from the ground? It's not necessarily altitude, but more about speed at altitude, Brian. Does that make sense? Oh, that's cool. Think like neat. So, like, if you're going like Mach 1 at 60,000 feet, you're not going to leave as much of a boom as going Mach 2 at 60,000 feet. It's not necessarily about how high, but also how fast. Remember what I said. The angles of those shocks change with speed, okay? This is a really important thing to understand, and this is very, very basic aerodynamics, supersonic aerodynamics, okay? Long story short, see the shocks here? These T-38s, I can already tell you right now, they are maybe at Mach 1.2, 1.3, something like that. They're not going very fast, supersonic, in supersonic terms. The supersonic regime, so supersonic speeds go from Mach 1.2 to Mach 5. After that, Mach 5 and faster, you're hypersonics. So that's like Space Shuttle, Dragon Capsule, X-37, Dream Chaser, Soyuz, the spacecraft are over in hypersonics, right? The SR-71 got close to getting into hypersonics, but believe it or not, this is just my personal opinion, I think the SR-71 could go into the hypersonic regime. I think it had the thrust to be able to do it with the J-58. I don't think the airframe could take that much heating. When you get into hypersonics, you really have to worry about heat. Heat becomes a very big concern. However, back to what we're talking about. So as you go faster, basically the further you approach Mach 5, right? This thing, the angle of the shock starts to change. And if the angles are changing, that allows for a tighter convergence distance between shocks, okay? Basically, they combine because the angles change. Make sense? And that makes a louder boom. If you go faster, you make a bigger boom. I mean, okay, I want to be very clear. That is a very layman way of explaining it. That's not the full detail, but that's the gist of it. The wakes combine, you get louder. So that's the kind of stuff we got to deal with. It's not necessarily, I mean, that's a good question, dude. It's not necessarily about altitude, but also about speed, Big bada boom. Yeah. Big bada boom. Remember, from the cab, remember? Big bada boom from the cab. Senoacta gamat. What does ectogamut mean? Never without my permission. Yeah. Okay, thought so. You know that movie too well. It's one of my favorite movies, man. 2 questions. 1, would this make something like Everglades Jetport either necessary, viable, or otherwise a good idea? Everglades Jetport, I'm not really familiar with that. Do you think the SR-72 could go hypersonic? Well, FaZe, the SR-72 doesn't exist. Okay, doesn't exist. Do I think we have stuff that can go hypersonic? Well, yeah, of course. Duh. The Space Shuttle is a hypersonic glider. That's from the 70s. Just saying. We already have things that go hypersonic that have people on board. All right, we have plenty of those things. So I don't think it's that unreasonable to think that, maybe we have something like that. I mean, considering Space Shuttle's a hypersonic glider from the 70s, that's 50-year-old tech at this point. I'm just saying. I'm just saying. Oh, yeah, the XB70. Oh, compression lift. Yeah, that thing is sick. Rocket Guy, yeah. Now, yeah, I mean, the SR-71 got close to... That's another... Rocket Guy, you reminded me. The SR-71, on paper, got close to hypersonics. On paper. Once again, I firmly believe that the SR-71 can go faster than what they're telling us, just because of physics. Those turbo ramjet J-58s are monsters. Like, that engine is disgusting. It's a disgusting piece of tech, like in a good way. Also, I do believe the XB-70 could probably skirt hypersonics. Yeah, hypersonics are a lot like supersonics, except the shockwave is on fire. Yeah. Like I said, the thermal load on the vehicle becomes a big problem in hypersonics. Basically, those shockwaves that I told you about, yeah, they're on fire. Yeah. Actually, they're not on fire. It's plasma. Even better. Yeah. So, like, here, this is part of the reason why, like, it's kind of a big barrier. A sound barrier. No. Why this is kind of a big barrier. You see how some of these shocks right here? Remember how I told you the shock angle, the angle of that shock as you go faster goes this way. It'll change. As you go faster, it gets steeper, right? The second one of those shocks crosses your aircraft, it's a plasma cutter. Yeah. The shocks at hypersonic is a wave of plasma. So it will do exactly what a plasma cutter will do if you took a plasma cutter to the wing. Yep. I'll give you another example, or I'll show you another thing here. That's the reason why the space shuttle, like if we look at the shuttle, here's a beautiful picture of Endeavour. If you look at the shuttle has a very like oblique nose cone, right? Because it's designed to take that basically a thermal lance and kind of shoot it out around the fuselage. But if you notice, that's made out of like gray material right there. This reinforced carbon-carbon. It's basically resistant to plasma. It's something that's derived from ICBM tech. Anyway, so you have the black tiles that everybody knows about, but that is the Achilles heel of the system. The reinforced carbon-carbon. That's the worst part. Now, check this out. Remember how I said your wake angle or your shock angle does change. Look at the wing. The wing has RCC on it, but it starts right here. See what I'm talking about? Starts right there. And then it moves out all the way to the edge of the wing. That's because the space shuttle is designed to slow down. It's a re-entry vehicle. So the angle, that plasma cutter, right, moves further and further away, but it does move out of the wing. The wing actually, the shuttle is designed to, the shuttle's wings are designed to fly through that hypersonic plasma shock. It's designed to do that. That's why you have thermal protection out on the front of the wings, but the angle of it does change, right? That's the difference between making something that goes Mach 25 and something that goes Mach 3. You really have to start worrying about thermals. And I'll give you 3 guesses just by looking at the shuttle. You know, the different parts of the orbiter that get closer to that plasma wake. I'll give you 3 guesses. Which side do you think gets closer to the wake? At the bottom. You can always tell on a hypersonic reentry vehicle where those plasma wakes go and how they propagate by where the dark tiles are on the vehicle. That's really kind of important. Wherever the darker stuff is where that plasma wake gets really close to the fuselage. Now, once again, the X-59, I just want to say this just for, just so we know. The X-59 is not designed to go hypersonic. It's designed to basically squash those supersonic shocks, not hypersonics. We haven't figured that one out yet. We haven't figured out how to do that just yet. But here, let me show you some imaging of the shuttle. Check it out. See the shocks? This is in a wind tunnel. This is doing wind tunnel testing. But that's what I'm talking about. But if you notice, you're getting some flow phenomenon here off the shuttle's wing. I can pretty much tell you exactly how fast it's going by where this is propagating over that wing. I'll tell you, this is low hypersonics. So this is like Mach 10 maybe, if I had to guess. If this shock was further forward, it'd be going faster. If it didn't exist at all, you're out of hypersonics. You're into supersonics. Where does the hypersonic realm start? Mach 5. The reason why in hypersonics, why it catches on fire is because air compression. You're getting basically air compresses up against the vehicle, even like a point. Air will compress up against that point almost infinitely. Even if you have like something super pointy. And this is the difference between like what a Concorde does and what a space shuttle does, right? You're infinitely compressing air up against that point, and basically, a plain English way of explaining hypersonics is you're going so fast, you're ripping the air apart, and when it rips apart, it catches on fire. Yeah. You're ionizing the compressed air. Basically, it's getting so compressed that it's heating up to a point where it's ripping air molecules apart. And when you rip air molecules apart, you get a tremendous release of energy in the form of plasma. Mm-hmm. Mm-hmm. We haven't officially figured that out yet. That's right. Yeah, officially. And look, man, all I'm saying is that the space shuttle is a crude hypersonic vehicle, okay? That's all I'm saying. And that's quite literally 50 years old. They drew up the plans for the shuttle and finalized the design in 1974. So program got on the books in 1972. They drew up the designs in 1974 and started making the things. Approach and landing test in 1977, first flight in 1981. Like I said, the space shuttle is a crude hypersonic vehicle, but the SR-72 doesn't exist. You understand? Right? Picking up what I'm laying down? Now, the Dark Star? I don't know. Tom Cruise. You know what I'm saying? You know what I'm saying? You know what I'm saying? Am I right, dude?
Discovery, go at throttle up.
Hey, WD-40, how does supersonic retropropulsion stop that hot plasma, and doesn't it just go through it? No. The law of conservation of mass. Shooting a bunch of hot gas out the bottom pushes it away. It does exactly the same thing as an ablative heat shield. And thanks for the 29 months, dude. Okay, WD, how nerdy do we want to get here? Okay. If you took the progress we had with computers and applied that to aerospace, yeah, ruinous for sure. But here's one to noodle on real quick. The aerospace industry is responsible for the tech industry. Think about it. The incessant need to miniaturize electronics enough to be able to put them on an ICBM. Where do you think that came from? Where do you think we figured out how to do that? The Apollo program. The more you know. But you're right. I do agree with what you're saying. Also aliens. Jellyfish aliens. No, that's totally not bird poop on the camera lens. Am I right? No, it's jellyfish, bro. Did you see that curious mark? Yeah, I did, Dot Blank. So, I knew the answer. Oh, you knew the answer. I just wanted you to say supersonic retropropulsion. Oh, all right. Thank you, but I like it better my way. They say you are the Lord of War. It's not Lord of War, it's Warlord. Thank you, but I like it better my way. Orange. Anyway, awesome rollout of the X-59. Actually, some good news, because the news for NASA this week has kind of sucked, to be honest with you. The Blue Origin news, though, the Blue Origin news is pretty freaking good, though. That's pretty neat. Just like auto racing trickles down to road cars. Bingo. The B3U does be looking good, though. Nooglins. Yes. This is why the air heats up in the shockwave. Ah, yes. Yes. Adiabatic compression. Oh, boy. Chad, I know you want to learn about this. Look at this. Oh, yeah. Yeah. Oh. Half of chat's like, no. Oh. Oh, yeah. Show me the math. Oh, Jerry, doesn't it make you feel good just to say that? Say it with me. I want you. Show me the money. Just show me the math. Show me the math. What's with all this math stuff? My brain. No, not learning. Oh, God. You're triggering equation allergies. Oh, sorry. Please inform us if you do in fact have a math allergy. Before you order, please inform our employees if you do in fact have a math allergy. You didn't inform me. But chat, it's okay. These aren't differential equations. Yeah, Taco, those actually aren't that bad. Even a moron like me knows what that's saying, I think. You know what we could do? We could figure out what that equation says. You know how we could do it? By reading. Look at the math. It's just staring at me menacingly. Did I see this? I don't know. I've seen this a lot today. People have typed that word in the chat. Oh, I do like that. I do like that, yes. Yeah, yes. Fun fact, adiabatic compression is also what internal combustion engines do. If you like cars, that math also applies. Because it has to do with gas compression, which compression stroke. Suck, squeeze, bang, and blow. I just said that and some people in the back went, what? What? What was that last part? How much coffee has EJ had today? I'm over being freaking sick, dude. I'm done with it. No, seriously, I feel better. I'm good. Did I miss the rollout? Yeah, Stretch. Here, you want me to show you? Take a look. Real quick. I'll check out that other space news in a second. And then we'll get back to cities. We're trying to frivolously spend cash as much as humanly possible. Possible. That's Pam. Pam's cool. She flew the space shuttle a bunch of times. Yep. Oh, it's a looker, Stretched. It's a looker. That plane looks sick, dude. It's definitely nice. Well, that won't fit a family of 4. But it could. Possible. Facility. Verify distance to target. 1 ping only. Yeah, right. Yeah. Pam, the plane, please. Oh. The camera in front of the canopy looks weird. Kind of wish they just used like perspex and just had like a tunnel that you look at. Don't choke. Like you had a tunnel that you look out. I don't know how I feel about using a screen to fly, but then again, I ain't a pilot, so I use a screen to fly all the time in virtual reality. How many clowns could you fit in there? Well, at least 1 skunk. Does that you could tell because. Am I weird in wishing that it had a periscope instead? My guess is that a periscope would be too turbulent, but yeah, I'm kind of, dude, I don't know how I feel about flying by screens. I've talked to pilots about this, and they're like, what's the word I'm looking for? No! The camera is essentially a periscope. Yeah. No third-person view? You don't know that. Hey, you have a third-person view when you back up in a car nowadays, all right? You don't know that. You don't know that for sure. It uses 3D modeling. Don't you get it? It's all fun and games until the camera turns off. Yeah, Stretch, that's why, like, I hope you have gauges. Dumb question, but do you have a VR headset? Just give me 1 second. Nah. Nah, not me. Nah, that ain't me. Nice VR headset? Yeah, I got it from some guy I know. He also gave me a shirt. I have a similar one in real life. It uses 3D modeling, guys. You don't get it. 3D modeling. That's for welding, right? Yes. All right. And now, on to something completely different. Nope, it's for hiding your poker face. But your poker eyes. Wild question, but have you ever played Real Fishing VR? Surprisingly fun game. No, I haven't. What's the purpose of the X-59? So the X-59, I mean, Pogo, I don't know if you looked at it, but it looks like a platypus that flies through, that flies. The reason why it looks like a platypus is because the plane is shaped in a way to make no sonic boom. Or, well, minimize sonic booms. That's the right way to say it. Yeah. That plane's designed to not leave a boom so much, just a thump. Just buh. So, sonic booms are directional. It's sound. Think of it like a speaker. Speaker is directional, right? You know, the side that the speaker is on, if you're standing behind it, it's going to sound different, right? Sonic booms work like that, in principle. They're directional. So, like, if a plane is up here, right, and you're on the ground, the boom is kind of angled off, and you'll hear it, right? It'll be, you know, like sound radiates out, right? Same idea, right? This thing has the speaker pointed up. So it just shoots the sonic boom up in the air. What little sonic boom there is, it makes it go up instead of down. It's directional, which is actually really cool. Just like you could change the geometry of a speaker to make it sound different, like the difference between like a bass and a treble speaker, right? Same idea. Sounds and stuff. Yeah, the idea is that it doesn't, you know, no sonic booms. The reason why we ban sonic booms is because you don't need something like Falcon 9's crackle every time a plane lands, especially if you live near an airport. It would literally be like a howitzer going off in your front yard pretty much every 2 to 3 minutes. Also, I'm not going to sit here and say that I don't like the people that move in next to an airport and then complain about a noise, but this I understand. Yeah. There's a difference between and every 2 minutes, you know, like a little different here. That's why they said it on the cast, but in the early 70s they banned supersonic flight for commercial travel over land. I'm all about that bass. No treble. Yes. Who isn't? Who isn't? That's a very good point. Yeah, like even in Top Gun, right? Permission to Buzz the Tower, like the sound that they made the plane make was like yeah, no. If you went supersonic that close to the tower, I'm not saying everybody in the tower would be dead, but also deaf at the very least. Yeah.
Discovery, go at throttle up.
Why not wait until Mach 1 until far away? Possibly Repairy. Thanks for the Prime sub. I mean, maybe. Why not wait until Mach 1 until far away? What do you mean, Driados? Yeah, it would shatter the glass, like, no problem. Like, yeah. And lots of spilled coffee. Yeah, that pass, if you look at like Top Gun, the first Top Gun behind the scenes, that pass with the F-14 at the over the Miramar Tower, that guy, he was not even in transonic, not even close. Like subsonic, like well into subsonic, because like I said, it's going supersonic. Yeah, that's like putting your ear up to the muzzle of a howitzer when it goes off. You don't, yeah, nope, don't want to do that. That would be a big mistake. There's a reasons why people stand behind like artillery and cannons and stuff. Like, there's a good reason for that. Yeah, you don't want to be on the receiving end of that. For multiple reasons, but you get the idea. Lift off, get up high, then speed up. Driados, here's the thing: sound propagates through the air pretty dang well. If you're going Mach 1, it's still gonna. It really well. I already explained this a little bit earlier, but altitude has something to do with it, right? But it's really about how fast you go. I mean, you're still going to leave a sonic boom at like 70,000 feet going Mach 1. You're still going to leave, people will still hear it. Could you have a hypersonic submarine? If submarines could fly, sure. Hypersonics referred to something moving through a gaseous medium, fluid gaseous medium, a dynamic fluid gaseous medium if you really want to be technical. Submarines don't fly. So, I mean, if you could somehow get a submarine to fly and then make it go hypersonic, then yes, sure. Hear me out. Jupiter submarines. No. You can't go hypersonic through water? No. Hydrodynamics are different than aerodynamics, and I'm pretty sure you guys know that. I'm pretty sure you're just messing with me. But also, I can't tell. I can't tell, man. What did it do? My brain hurts. What were we doing? Should we go back to playing cities? I want to go back to playing cities. It's either, here, I'll give you a choice, chat. We can either go back to playing cities, or we can sit here and I can lecture you on adiabatic compression. Yeah? 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 No. 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 Please! NASA has selected 12 companies for ISS services, 7-year contract to extend for 2 years to extra 22. Okay, I got it. I got the link before it went off the page. Wicked. I like that plane too. The F7 looks really cool. I want it. I want it. Yes, give us the math. Will the lecture include supersonic submarines? No, I'll give you subsonic external tank. It's kind of submarine shape. I don't know if that music is... Oh, hello. Hey, baby. I see you have spray-on foam insulation. I have spray-on foam insulation, too. As long as you could say Bazinga in the lecture. Can we please talk about aliens? The aliens are amogus. Especially the jellyfish, Emery. The jellyfish is coming to get you, dog. Look out, it's right behind you! That's the California Science Center exhibit. They're stacking a full shuttle stack and they're going to put it inside of this building, which is really, really freaking cool. The tank's missing some parts, though. No, those parts are there. That's kind of neat. Made you look. I saw that one. No, you didn't. You didn't look behind you. Theoretical physics for 1,000, please. Okay, here's your lesson on theoreticals. I think it's going to work. We should go test it. Yep, there you go. There's your theoretical physics lesson. You should go test that. Yep. Quantum physics? All right. It's here. Now it's over there, and I have no idea why. Cool. There you go. You're welcome. It's like the squiggly line in your eye fluid. Oh, squiggly line in my eye fluid. Why won't you go away? Oh, now I'm over here. It's like quantum physics. It's like that. It's like raw power. It's like watching Shark Week. Wasn't this about airplanes or something? I'm gonna go back to